My name is Brian Beres. I'm a research scientist with Agriculture Canada in the area of agronomy. I spend about half my research time devoted to winter wheat and the other to spring wheat and typically oil seeds and cropping systems, do a lot of rotational work. So Phil did a great introduction around the whole concept of PGRs and where they fit and the timing, and why I was interested on a winter wheat production side was how does it fit in our overall, overarching goal to basically manipulate the canopy of a crop to optimize growth in a way that enhances our yield and stabilizes our yield. And so that's why we're looking at a PGR. So we're looking at it from the perspective of trying to look at its effect on super short varieties like a flourish, to see how it interacts with an actual RHT gene, reduced height gene, to extreme, to where we picked probably one of the tallest cereal crops, which is a fall rye. And then more conventionally over there in a winter wheat variety called Moats, which actually, coincidentally, and was part of the impetus behind this, had some lodging issues in the first year of its breeder seed and commercial seed blow up. So the timing here was kind of interesting. So in this case, we're using the Trinexapac, working with Syngenta on this one because they're kind of keen to introduce this into winter wheat as a starting point. And so what we did is we had two different timings going in at late tiller and then more of a pre-boot stage. So the late tiller would be that 31 or the Feeks 4-5, and pushing it a little bit later into the window of a Feeks 7-8 or a 37. And if you look at some of the information on this where it's commercially available, like in the US, the window's actually kind of wide on it, up to even 41 with winter wheat. So it's a little more forgiving, and so we're kind of within the safe window. One a little earlier, but one a little later, but generally speaking, they're well within that window. And so I would have guessed that late tillering would have been more optimum. You can come up here and tell me what you think. There's two different doses, 0.6x of the recommended rate and then 1x of the recommended rate. So if we look at one like this is the full rate at tillering, and the one by Morton there is the pre-boot. So which one do you think had more of a response to the PGR? Pre-boot, late tillering? I heard pre-boot. Anyone want to argue with that? No? Good answer. So last year was our first year. I would have bet money on late tillering, but pre-boot both years is at least on the height side of things, although statistically really not different, but it's definitely creating a more pronounced effect. And what's interesting too, Phil alluded to that, we're over with our site over on a farm 3 miles east of here, and we're pushing it pretty hard to try and cause it to yield, which is another reason why we picked this one. But the rye and the moats haven't gone down yet in either year, and so I'm looking at that thinking we're not going to see much of a yield bump at all, because it's not it's not dramatic, but sure enough, with our data, the PGR actually, compared to a control, significantly increased yield. And Phil alluded to that as well. Why do we see that? Well, with the plant, which is kind of surprisingly when you apply it, especially when you're applying it a little later, that plant's going to repartition that carbon, not so much into the photosynthetic machine anymore, but it's going to push it up into that viable fruit or the seed mass, and so you're getting a little bit better seed out of it, and you're not dramatically reducing biomass. In fact, in our case, as far as how you're actually affecting the architecture, other than a little drop in height, you would think that stem would actually widen out quite a bit, or that wall would, but it's very subtle. In fact, we only had, Moats was the only variety out of the three that actually significantly affected stem wall thickness. So it's not dramatic, at least in the first portion of this study. Stem diameter, I would have guessed we would have actually widened out the stem a bit. Not at all. At least on, using a fairly rigorous statistical analysis of it, but there is a trend with actually the late tillering, where it seems to be widening a little bit more versus a check. So I would say fairly subtle influences on the canopy itself, but definitely we're affecting yield, which is great because we're not really doing a whole lot as far as mitigation of lodging yet. Yep.
Do you guys see any protein increases as well, or just yields?
No effect on protein yet, anyway. We're growing this next year, not just at the 2 sites here in Lethbridge, but we've got it up in Lacombe and out by Melford as well. And I think it's at Brandon too. So we'll get a little bit better idea around some of those other effects later on when we have more site years. What do you think about weeds and PGRs? Would that affect weed? Would that help the weeds, hinder the weeds? Josh is smiling, but he's thinking I'm trying to pull a fast one on him. Not really. You want to be careful with your application of PGRs, making sure that you're on top of your weed control, your weed management. Because one thing we saw, and it was just anecdotal, but it was very pronounced out at the Fairfield site. We had a bit of a wild oat population pressure in our first rep, and where we shortened moats, we had definitely more wild oats there. So just be cognizant of, while using the PGR for the benefits, that be careful around those issues of weed management. And then obviously application's pretty critical as far as if it's got the long residual like manipulator. You want to make sure you're not going too late with ones like this. This one's probably not going to be an issue, at least on the winter wheat side. So yeah, I don't know if our other groups here yet. Any questions on this study? Very good. We'll just make our way down this way. So around the whole idea of canopy architecture management and to some degree lodging, that sort of spawned this study, and I'll just turn you loose to have a look at it after I make a couple of introductory comments. So one thing that we've been doing as part of our winter wheat suite of projects is looking at a lot of enhanced efficiency fertilizers, but we kind of neglected the liquid side of things. And so this study is in part to address that, but also we're trying to see, because there is a school of thought out there that's opposite to mine. Mine is, I want to see growers and you as consultants pushing your growers to push seeding rates. And so we've refined seeding rates for winter wheat, where we've got everybody probably at a 450 seeds per square meter rate, or 45 seeds per square foot. I've done work on spring wheat that actually shows, especially in something like Durham or a higher yield potential spring wheat, actually 450 works pretty good as well. But conservatively, I would, if I were a grower, I would probably be around 400 with my spring and 450 with my winter. But anyway, there's this idea, well, what if I went with a lower seeding rate and just let the tillers take over, especially in a crop like winter wheat with as high a maximum tillering capacities as you get, and then I go in with my liquid N, and that'll actually manage those tillers. So that was sort of the two hypotheses around this one. So basically, we've got combinations of split applications here using UAN, where we're, with winter wheat, it can probably use up to 170 pounds per acre of N if it had it. So I was assuming that a residual would be somewhere in the neighborhood of 20 pounds. And we've got combinations of what we're adding to that of 150. So could be as low as 10 pounds at planting and the remainder put on in spring, or it could be more moderate, like 60 at planting, 70 later on as well. And so that's what you see with this one. And generally speaking, the initial results there aren't a big surprise. The seeding rates have the most dramatic effect. Anything with that higher seeding rate is doing far better than the lower seeding rate. The higher seeding rate being 450, the lower one being 250. And there are a lot of growers, especially when I started this work, that were at 250. So that's the quick and dirty on this one. Any questions?